So you are welcome to today's class. In today's class, we are going to be looking at equation of a straight line with gradient at one point form. So we are still under coordinate geometry, and the subtopic is equation of a straight line with gradient at one point form. So in this subtopic, we are going to consider a xy plane. So we are going to have xy plane on a straight line. So we draw xy plane on a straight line. This is x-axis, and here is what y-axis. So here is the origin, that is where the x and y-axis meet. So we are going to consider a line AB, such that we have line AB pass through point P of coordinate x1, y1. Then we have a line AB passing through the what? Point Q. So line AB passing through the point P and Q. So Q is of variable x, y. So what we are going to do, we are going to form a right angle triangle at P and Q. So we have the horizontal axis of point P, then we have point. So this is the vertical axis, then we have angle 90 here. So the angle of slope is given as theta. So here we trace this to the x-axis, which is x1, that's point x1. Then we have Q to x-axis, which is point x. Then the distance between x and x1 is x minus x1. So the same thing goes for what? The vertical axis. Then we have P to the y-axis, we have y1. Then Q to the y-axis, we have variable y. So the difference between, or the distance between y and y1 along vertical axis is y minus y1. So don't forget, our element is what? Equation of a straight line with gradient and one point form. And we should also recall that gradient is equals to tan theta. So whenever we have angle of slope and we have to find the gradient, the formula to use is gradient equals to what? Tan theta. So we can now make use of trigonometry ratio that says opposite over adjacent. That is tan theta equals to what? Opposite. So opposite to theta is y minus y1 all over adjacent to theta is x minus x1. But from recall, we have f to be equal to what? Theta. So it will now be f, which is equals to y minus y1 all over x minus x1. So the equation of the line with gradient and one point form is m equals to y minus y1 all over x minus x1. And we can as well write it as y multiply. So we have y minus y1 multiplied by 1. That is y minus y1 is equals to m multiplied by, that is m into s minus x1. So this is the equation of a straight line. This is the equation of a straight line with gradient m and passes through the point x1, y1. So this is the formula to use. So when you are given problem on the equation of a straight line with gradient and one point form. So let's go to the first example. So example 1 says, find the equation of a straight line with slope 2. Don't forget, slope and gradient are the same. So invariably, gradient is given as 2. If it passes through the point 3, minus 2. So solution. So slope is given, which is equals to the gradient, which is equals to m, which is what? 2. And the equation of the line passes through the point what? 3 comma minus 2, which means s1 comma y1 is given as 3 comma minus 2. So it means s1 is what? 3 and y1 is minus 2. So the equation that connects the gradient at the one point form is y minus y1 equals to n into s minus s1. So y will still remain y, x will still remain x. So what we just need to substitute for is the gradient and x1, y1. So y minus y1 is what? That is minus 2. So minus 2 equals to gradient 2 into s minus x1, 3. So we now have y plus 2 equals 2 into s minus, or you can just multiply. 2 multiplied by s, that's 2x. 2 multiplied by minus 3, minus 6. So y equals to 2x minus 6. Then transfer 2 to the other side, we have minus 2. So y equals 2x minus 8. So the equation of a straight line with gradient 2 and passes through the point 3 comma minus 2 is given as y equals to 2x minus 8. So that is that on question number 1. Okay, the second example says find the equation of a straight line passes through the point 2 comma 3 with slope 1. So here we have the point given is s1 comma y1, which is equals to 2 comma 3, and the gradient, which is the slope, is given as 1. So the formula is m equals to y minus y1 all over x minus x1. So you can as well make use of this. So from here, slope is 1, so we have 1 equals to y minus y1. So y1 is 3, so y minus 3 all over x minus 2. So over 1, so you now cross multiply. So if you cross multiply, it's going to be y minus 3. So 1 into y minus 3 equals to 1 into s minus 2. So we have y minus 3 equals to s minus 2. So we have y equals to s minus 2 plus 3. If you transfer minus 3 to the other side, to change to plus, so y equals to s plus 1. So the equation of the line that passes through the point 2 comma 3 with slope 1 is given as y equals to. So question number 3. So question number 3 is of different form from 1 and 2. So the question is obtain a point. You should know that if for any point on xy plane, you must have both x axis and y axis. So which means we are looking for x1 and y1. So through which a line y equals to 3x minus 4 with slope 3 passes through the point, passes through. So obtain a point through which a line y equals to 3x minus 4 with slope 3 passes through. So to solve this type of question, so we have the equation of the line given. So the equation of the line given is y equals to 3x minus 4. And we have the gradient to the what? Gradient is given as 3. So you now go back to the equation of the line with gradient at 1.4. And equation of the line with gradient at 1.4 is given as y minus y1 equals to m into s minus x1. So what we are looking for is x1, y1. And to do that, we have y minus y1. We don't know it, which is y1 equals to m. M is given as 3. So 3 into x minus x1. So we now express this equation in form of y equals to, so let's call this equation 1. So we are going to express this equation in form of y equals to 3x minus 4. And to do that, we have y minus y1 equals to 3x minus 3x1. Or you can as well leave it, you can leave it as 3 into s minus x1. So y equals to transfer y1 to the other side. So we have y equals to 3 into x minus x1 plus y. So from equation of a straight line is greater than 1.4, so we have y equals to 3 into x minus x1 plus y1. So we call this equation 2. So the next thing to do is to compare equation 1 and 2. So if you compare equation 1 and 2, we are going to have y to the y, then 3 equals to 3. Therefore, x equals to x minus x1. So from here, you make x1 the subject. If you transfer x1 here, it's going to be x1 equal to x minus x. So x1 equals to x minus x is 0. So it means x1 is 0. Then the second side, we have y1 to be what? Minus 4. Therefore, y1 equals to minus 4. So the point through which equation y equals to 3x minus 4 with gradient 3 passes through is point s1 comma y1, which is equals to 0 comma minus 4. So we can check whether the point here is correct. So to do that, we are going to make use of what? So we are going to make use of the equation of the straight line. Equation of the straight line with gradient at 1.4, which is y minus y1 equals to f into s minus s1. So y minus, what is our y1 here? That is minus 4. So we have minus 4, which is equal to the gradient. Gradient is 3 into s minus 0. So we have y minus times minus is plus. So y plus 4 equals 3 into x. S minus 0 is x. So we have y plus 4 equals 3x. So y equals 3s minus 4. So which is the original equation given. So which means the line y equals to 3s minus 4 truly pass through the 0 comma minus 4. So that is that on question number 3. So thank you.